Rates of change. At which point on the graph of f of x equals to x minus 2 cube minus 3 is the slope of the tangent horizontal? Now, we are not given the point. We need to find the point in this case. So it's kind of a different problem. And second complexity is that we have a cube here. It's not a square, right? So you need to know what is a minus b whole cube. So these are the two things which are very critical about this question. So let us see how to solve it, right? We will use difference quotient method to find instantaneous rate of change. And when we say that the slope is horizontal of the tangent, that means that the instantaneous rate of change at that point should be 0, correct? That's what we're trying to figure out. What is that point? So we know instantaneous rate of change is equals to f of a plus h minus f of a over h, right? Where h is something which is very, very small, right? Now, so where h is very, very small as compared to 1. Most of the time we take h equals to 0.001 by default, right? And at times we also use h as approaching 0. So in some of the answers we can really plug in 0, right? Because the other numbers are very big. That is the reason. We are not putting 0 there, but we are saying that if the number is 10, and then 10.001 is same as 10, right? So for practical reasons we do that. And therefore we also use a term which says estimate slopes, right? So we are actually estimating, right? So when you are estimating things, then you can also do that approximation. So these are the reasons why we really plug in 0 for h, right? Now, fa plus h. For this function, what is fa plus h? This is something which most of the time is critical for this kind of a function. Let's calculate this individually. So a plus h means replace x with a plus h, right? So we can write this function as, instead of x, I'm writing a plus h. So we will write here x is replaced by a plus h minus 2 whole cube minus 3, right? Now, so we get some number here which says a plus h minus 2 whole cube. Now, how to expand this? So you can use Pascal's triangle to expand this if you don't really remember. And Pascal's triangle is something like this. Let me draw it in a different ink here. So let's say this is 1. We started with that. So we move out in once, and then we again move out and in. And this is how you combine them, right? And then we go to the third level. First is the 0th row, first row, second row, and that is the third row. So 1 plus 2 is 3, 2 plus 1 is 3, and that gives me 1. So these are my coefficients, and when we have a term like this with power of 3, then the sum of exponents will always be 3, right? So basically what we get here is, we'll apply this formula now. Now let's assume this is one component, right, for the time being, and then we have a and this as, make it a binomial term kind of, right? So write a cube here plus 3 times the first one, and the second we are handling it as together, right, plus this, and then we have plus 3 times, and then again, a square, and the product is 1, a, and h minus 2 becomes a square this time. So this 2 and 1 is 3 for us, and plus h minus 2 cube, right? So that is the expansion of the first part, and then we have minus 3 here. So that is how this function will look like. Now we need to expand this, correct? Now, so we get a cube plus, and all these terms inside. So we have 3 a square h minus 3 times 2 is 6 a square h, and then we have this time h minus 2 whole square is to be expanded, right? So which is I'm kind of running short of space here. So 3a. So we know this is h square minus 2ab, which is 4h, and plus 4, right? And I'll write this h minus 2 whole cube here in the denominator. Oh, I mean not denominator, I mean the next line. So h minus 2 whole cube I'll write here now, which I'll use again the same formula. So it gives me h cube plus h cube. And when it is minus, right, so whenever we are multiplying with a component of this, it will change the sign to minus, right? So this term will be now minus h square, and we have 3 as a coefficient of h, and times 2, right? So we are using 2 to the power of 1, and that is minus 2 to the power of 1, and I wrote minus here for that. Now then we get plus 3 times h and 2 square, which is 4, and then the cube of 2, the cube of minus 2 basically, which is minus 8, right? And then we have minus 3 here. So that is what we get. And now let's simplify this a bit. Now, so that means we got so many things here to simplify, but a cube is very clear to us, and 3a square h. So first let's write down 3a square h minus 6a square h this should be 6a square. There is no h here. Yep. Right. So it is 3a square h minus 6a square, right? And then we'll do this. 3a plus 3ah square minus 12ah plus 12a. And then we have all this, right? H cube minus 3 times 2 is 6h square, and then we have 12h minus 8 and minus 3 gives me minus 11. So this is what is fa plus h for us, right? And now we know all this, right? And now what is f of a? So f of a will be a minus 2 whole cube minus 3, right? So a minus 2 whole cube. So f of a will be equals to a minus 2 whole cube minus 3. So this is equal to, let me write it in different ink. So we'll use the same expansion and write this, which is a cube minus 3 times a times 2, right? Which is, let me now write a times 2 plus 3 times, this is a square, a times 2 square, which is minus 2 square, which is 4, and then minus 2 cube, which is 8 minus 3. So this could be written as a cube minus 6a square, and that is 12a plus 12a minus 11, right? Now, so we have fa plus h and fa, and so now we can write down what is instantaneous rate of change for this particular function, which is f of a plus h minus fa over h, right? That is what it is. Now when we do, we got all this and minus this, right? So instead of writing there, what I will do is I'll try to simplify it here itself. So that is fa, right? So some of the terms, we're taking away this from the whole line. Some of the term will get cancelled, and I'm trying to cancel those terms here. And then we will rewrite our expression, correct? So that is a strategy which I'm going to adopt here. So let me do it like this. So minus 11 is kind of this, right? Then we have 12. Now 12. So 12a, so we did a mistake here. So it was 12a, not 12, right? So let me write this back as 12. It's a good correction. It's 12a. So 12a will go with some term for sure, which is this one. Minus 6a squared will go with minus 6a square, and a cube will go with a cube. So we got rid of some terms. Now what you notice about rest of the terms which are with fa plus h, you'll find that h is common. You see this? Now I'm underlining this h because I don't really want to write so much. The idea here is to show you how to get the answer, right? And you can do the rest of the math to get the answer. Now we can factor out this h. When we factor out this h, it will get cancelled. You understand? It will get cancelled. So what are we left with? So whatever we are left with, I'm going to write that without these h, right? So imagine I wrote h, factored out that h, and here we have this h, right? And now I'm writing rest of the terms inside the bracket. So it's exactly what it should have been, right? Without really skipping a step. So we have 3a square here. And then this cancels, so we have 3ah. And then we have minus 12a. And then we have h square. And then we have minus 6h. And this h cancels, so plus 12. So this is what we get from here. Now here, what you notice is that this h over h will be 1, correct? Now second thing what you have to note is this part. This is a cube, so if you do cube of 10, it becomes like 1000, right? So h.001 is very small, so the terms which have h in it, I will make them 0 because they're as good as 0, right? So basically, we are left with the terms without h, right? So the instantaneous rate of change for us is actually equals to, let me use different things so that it at least helps us. Now it's 3a square and minus 12a and number 12. That is, and I'll write approximately because it is close to, correct? So that is your instantaneous rate of change for this expression. And it says, at which point on this graph is the slope of the tangent horizontal? That means you have to equate this to 0. So at that time, instantaneous rate of change will be 0. So now you have this as 0. So you have a quadratic equation here, right? Where the slope is 0. So let's try to solve this. We can take 3 common, right? That's good. So we have a square minus 4a and plus 4, right? So that is the quadratic equation to be solved to get a, right? Now getting 4 with product also as 4 is kind of difficult. So you can get actually minus 2 and minus 2, correct. So you can do that. So minus 2 will give us. So we get 3a minus 2 whole square. Perfect. So a minus 2 whole square is this, and if that has to be 0, that means we get our answer that a is 2. Do you see that? So we know this is possible for only this to be 0 means a equals to 2. Do you see that? So at a equals to 2, the slope will be 0. Seems to make sense because this is a cubic function, and this cubic function is translated 2 units to right and 3 up. So if you try to sketch this cubic function, it will kind of look like this. Do you see that? And the point where it has a horizontal slope is kind of here, where the concavity changes, right? And that is this point, which is 2 minus 3. So if you calculate, that value will be 2 minus 3, right? This point, right? So it makes a lot of sense. So the idea here is to teach you a couple of things. One, that sometimes it could be very cumbersome doing calculations, so it is better to do fa plus h and fa separately and try to solve them. Second, use Pascal's triangle if these degrees or the exponents are higher. I could have written to the power of 5 and made your job hell, but well, the method, if you know, you could run into a few pages, but you'll get the right answer. And then try to simplify it as I've tried to do before you. And you'll surely get your answer. So that helps, I think. Thank you and all the best.